to the tutorial for Chapter 5, Section 1, Rate of Change and Slope. And so let's take a look at the first type of problem we'll end up seeing, and that's asking us to find the slope of each line. So we have to figure out what slope is. So basically when we're dealing with slope, we're dealing with a rate of change, and when we look at a rate of change, we're looking at the change in two variables. We're looking at the change in y, and there's a symbol I use for change. The symbol I end up using is a triangle. So there's the change symbol I'm going to use. So we're taking a look at the rate of change of our two variables, the change of y over the change of x. And so another way to say that is rise over run is what common times people end up talking about slope. They talk about the rise and the run. So rise means change in the y direction, run means change in the x direction. And so that's what we're looking for. And there's four different types of slope, and we see each type here. And so this type of slope is a positive slope. So whenever our values of x and y both increase, so x increases as y increases. And so whenever we are looking at that, you can see how if I start at a point, like let's say I start right here, I can see that the y values are increasing by 2 as the x values increase by 1. And that's what the rate of change is, or the slope. And so that's what I'm going to write down. So the rate of change is y's increase by 2, x's increase by 1. And so we end up using a variable m to represent slope. You can think of it as m stands for like mountains, and mountains have slope. And the slope of the line would be 2 to 1. So the change of y is 2, change of x is 1. And so we can see that again if we make these little slope triangles. Sometimes it's a little easier to see that slope, and it's always consistent. So every single time you see how that y value changes by 2, x value changes by 1. Here, this is a negative slope. Now I know it's negative because it's going downhill from left to right. And so when we take a look at negative slope, we see that the y values decrease as x increases. So you can see how the y values are decreasing as the x values increase. And we can see if I put a point right here, it looks like it crosses those intervals. It's going down 1 and then to the right 2 each time. So you can see how the y values are getting smaller, x values get bigger. Y values smaller, x values get bigger. And so we can write that as a fraction. So again, slope is the change of y over the change of x, or the rise over the run. So this time we're not rising but falling. We're going down 1 and then over 1. So that makes negative 1. That's what our slope is. So this slope is called zero slope. And so zero slope means that the y values do not change. Y values are constant. And the x's as x's increase. So if we look at this point right here, we do not go up. We just stay constant, but we go over. We go over and over each time. So the slope is represented as 0, because I increase 0 over 1. And that just makes 0. So that is a 0 slope. So far we've seen a positive slope, we've seen a negative slope, and we've seen a 0 slope. This one is a vertical line. This is called undefined. Undefined slope. So undefined slope is when we have the y values increase and x values as x values stay constant. And so the x values are not changing, but the y values are. So that would look like this. You see how you go up 1, but you do not go over. You go up, but you do not go over. And so that slope would be represented this way. We would have 1 over 0. Because, again, slope is always the change of y over change of x. Now this does not make sense to us. We cannot have 1 over 0 because a fraction is represented as a part over a whole. And so what this would represent is me giving you one piece of pizza when there is no pizza. So you can't have one piece of pizza if there is no pizza, so that makes no sense to us. So we say there is undefined slope. Undefined. So that's what we'll end up seeing are those three different types of slope, either a positive, where x and y's increase, negative when y decreases but x increases, or zero slope is a flat line. When y's do not change, they stay constant, x's increase. And then undefined slope where x's stay constant but y's increase. So from there what we're going to do is we're going to find the slope given just 2 points. And we're going to use a little formula. So remember, our slope is the change of y over change of x. That's what the slope represents. And so what we're going to do is the change of y is just the difference of the y values. I write it as y minus y1 over x minus x1. Now in the book you might see it as y2 minus y1 over x2 minus x1. I try to use as few markings as possible, and so that's why I just use y minus y1. And so what we do is we treat one of the points as x and y. The other point is x1, y1. And we take the difference of the y values. So it doesn't matter where you start. I'm going to start with this point here. And I have 5 minus 2, because those are the two y values. See, this is a y value and this is a y value, over 4 minus 6. Now notice, since I started with the 5, I have to start with the 6. I'm sorry, I have to start with the 4, and then go to the 6. So I do the subtraction, and I get 3 over negative 2. And that's the same thing as saying just the opposite of 3 over 2, or I could put negative 3 over 2. Typically, people like to see the negative sign on the top of the fraction, and either one is fine. So on this one, same sort of thing. We're doing the change of y over the change of x. So I am going to have the first point be x and y. The next point is going to be x1, y1. And so I just substitute. So I have negative 4 take away negative 3. Down below I do 8 take away negative 6. And so I add the opposite. So when I add the opposite, this becomes a negative 1. And add the opposite here, you get positive 14. And that is our slope, negative 1 over 14. On this one, same sort of thing. This is my x and my y, my x1 and y1. So I'm going to set up my fraction, negative 3 take away 5 over negative 2 take away 6. So I'll add the opposite again, and that makes negative 8 over negative 8, which just makes a positive 1 as the slope. Last one of this type. So I'm just taking the x and the y value and subtracting from the x1 and the y1 value. So it's 8 minus 3 over 3 minus 7. So when I do the subtraction, 5 over negative 4. Again, if you like the 5 or the negative sign on top, that's fine. They both mean the same thing. So let's take a look at the next set of directions. We've got some word problems, and what they're asking here is, without graphing, tell whether the slope of the line models each situation of positive, negative, 0, or undefined. So again, when we're looking at positive, we're looking for both positive values. Positive slope, again, looks like this. X's and Y's are both increasing. Negative slope tells me that the Y's are decreasing as X's increase. Zero slope means we have a flat line. And a undefined slope means a vertical line. So it says the cost of a ticket at an amusement park is $19.50 for one ticket, $78 for 4 tickets. Notice that the price increases and the tickets increase. So our y values increase as the tickets also increase. Now I know that the y value represents the dollars because that is a dependent variable, where the number of tickets is independent. We can buy any number of tickets, but the cost is always dependent on the number of tickets you buy. And that'll be the next situation that we see. So this is a positive slope, and then they want us to find the slope, and so the slope is $19.50 to 1. And that would be at $19.50 for one ticket. So look at this next one. It says there's a late fee of $2 regardless of the number of days. So the number of days does not matter. every single time it's going to end up being just a $2 late fee. So that means it's going to be a horizontal line, and that means that we have zero slope, and we'll end up with a slope of 0. Since there's zero slope, 0 means that's the slope as well. On the trip, Jerry has it on cruise control at 60 miles an hour for 4 hours. So if I was to show this, if this were the graph, and they didn't want us to, but if that was, that would mean that 60 miles an hour is not changing. So if this is my independent or dependent variable, where time is independent, there could be any number of minutes or hours or seconds I'm going, but the speed depends on the time. And so that means that we have a constant y value. So that means it's going to end up being another one of those horizontal lines, 0 slope. And of course 0 is going to be the slope. Now it says the context states that every day past the contract states that every day past the agreed upon completion date, the project is not finished, the price reduced by $25. So every day, that means days are changing, and then when we go every day, that means those days are increasing. So the x values increase as the y values are decreasing because we reduce by $25. So it would look like this. It would be a negative slope, and it would be negative 25 over 1 day. So negative $25 per day. So here we have to state the independent and the dependent variables. So independent and dependent. Independent means that it obviously is free to be any number of units, where dependent depends on the independent variable. And so when we do this, again, depends on. And so when we look at it, we need to see which depends on the other. So Shelley delivers 12 newspapers after 20 minutes, 30 papers after 60 minutes. So you can see the newspapers are depending on minutes of time going. So what we have is the independent variable is going to end up being time in minutes, and the dependent variable, dependent, is newspapers. And so the newspaper is delivered. And so if I was to write the slope, or the rate of change, it would just be 12 over 20. And that's important because once we know what the independent variable is, then we know that goes in the denominator. The dependent one goes in the numerator. And then I just reduce. So I take out a common factor of 4 from each of these, and I have 3/5. And so if I made that into a decimal, 0.6 newspapers per minute. So that's how many we're delivering, and that can help you figure out how long it will take you to do it. Or you could say 3 newspapers over 5 minutes. So it says 2 pounds of apples cost $3.95. So pounds is independent. It doesn't matter how many pounds you purchase, but cost is dependent on pounds. And so that's going to end up being our situation. And if I set this up, I have $3.98, and that is for 2 pounds. And so if I go ahead and do the reduction, that leaves me with $1.99. $1.99 per pound. And the last one, an airplane ascends 3,000 feet in 10 minutes. The feet depends on minutes. So our independent variable is minutes, or time, and our dependent is feet. And so typically, time is typically going to end up being our independent variable every time, because we always have to have time increasing to be able to do anything. So that's why it typically is. So we set it up this way, 3,000 feet per 10 minutes. And then you just reduce. So 300 feet per minute. And that's what's valuable about this, is this way we can set up an equation to figure out how long it's going to take us to maybe go 20 feet or 30 feet. So those are the types of problems you're going to see on your homework. Good luck.